We're going to talk about covalent compound nomenclature today. Recall that on your periodic table, nonmetals are found to the right side of the stair-step line. Generally speaking, there's hydrogen also, which is on the left side. And metals are generally found to the left side of that stair-step line. In our consideration of chemical nomenclature so far, we've only been looking at ionic compounds. An ionic compound is one that contains a metal element, or ammonium ion would count in it. And when we write formulas, they're the lowest ratio of atoms possible. So for instance, if I have two sodiums and two chlorines, I know that sodium's a metal and chlorine's a nonmetal. I would reduce the ratio of atoms in that formula so that it's Na1Cl1. Covalent compounds, by contrast, contain only nonmetals. And when we have a formula, they exist the exact number of atoms. Do not reduce the formula. You wouldn't reduce a 2-to-2 ratio of atoms in the formula if it's a covalent compound. Covalent compounds also have unique nomenclature rules. They're actually very straightforward. Name the first element in the formula. So whatever that element is, write its name down. Name the second element, changing its ending to "ide." That's similar to what we saw for covalent compound nomenclature. This part is new. Add prefixes to indicate the number of atoms present. So you've all heard of carbon dioxide. The di means that there are two oxygen atoms in carbon dioxide. There's one little rule. I'm going to show you a list of prefixes shortly. Do not use the prefix mono for the first element in the compound's formula. We'll see some examples of this in a second. First, here are your prefixes. Most of these are fairly straightforward. Mono means one. Di means two. Tri, like the sides of a triangle. There's three of those. This one's a weird one. Tetra means four. Penta is five, like a pentagon has five sides. A hexagon has six sides, so hex is six. Hepta means seven. Octa means eight. And to be honest, you would rarely encounter prefixes other than this. There may be deca for 10. But these are the main prefixes that I do need you to know when naming covalent compounds. Let's go through an example. Let's say we're naming BF3. On your periodic table, if you locate B for boron and F for fluorine, you'll see that both of those are to the right side of the stair-step line. So we've got a covalent compound here. So find the elements in the formula. Ask yourself, are they to the left or to the right of the stair-step line? In this case, both elements are nonmetal. So we've got covalent compounds, and we'll follow the covalent compound nomenclature rules. That means we're going to use prefixes to indicate the number of atoms present. In this case, there's one boron and there's three fluorines. Okay, so you might ask, I remember that the prefix mono means one. Why isn't it monoboron? Well, you never put the prefix mono for the first element. You would put it for the second element if that were relevant. It's not here because there are three fluorine atoms in the formula. And the prefix for three is tri. So boron, trifluor, and then don't forget to change the ending to ide. Let's tackle some examples together. Here are three compounds that we're asked to write names for: N2O5, NO, and SF6. First, a quick glance at the periodic table would enable you to figure out we've got nothing but nonmetals. All of these elements are to the right side of the stair-step line. And so we're dealing with strictly covalent compounds. So we're going to do the prefix naming system, the new naming system we just covered. In the first compound, N2, okay, what's the prefix for two? Di. Now, we do use prefixes for the first element if it's not mono. So we're going to write dinitrogen. And then for the O5, pentaoxide. You could usually shorten that a smidge just to make it easier to pronounce. It's not a big deal if you don't do this. But this is called dinitrogen pentoxide. 2 nitrogens, 5 oxygens. The next one, NO. Okay. We do not use the prefix mono for the first element. So we're just going to write nitrogen, not mononitrogen. And for the second element, we do use the prefix mono. We use prefixes, any prefix for the second element. So we're going to write monoxide. If you wrote monoxygenide, that would be fine. It's usually chemists shorten that ending to make it more pronounceable, but it's not a big deal if you write oxygenide or like up above pentaoxide. It's totally fine. SF6, again, there's one sulfur, so the prefix would be mono, except we don't use mono for the first element. For the second element, you use it no matter what the prefix is. In this case, 6, so hexa, sulfur, hexafluoride. All right. This one, the nomenclature kind of comes quickly for binary covalent compounds. All right, next task. They're going to give us 3 formulas, and we're asked to write, or they're giving us 3 names, and we're asked to write formulas. Notice that in all of these names, there are prefixes. See the di in the first one, tetra and hex in the second one, and in the third one, there's mono is the prefix. Okay, if you know your prefixes, this one's pretty straightforward. Dioxygen, that's O2. Difluoride, that's F2, and that's it. You don't need to reduce the ratio of atoms in this compound. You just write whatever you see as indicated by the prefixes. The next one, tetra is the prefix for 4, phosphorus, so P4. Hexa, or they shorten it to hexoxide, but it would be hexa is the prefix, and oxygen is the element, so O6. And the last one, you probably have detectors for this substance in your house, carbon monoxide. Remember, the first element doesn't get mono as the prefix, so it's not monocarbon monoxide, it's just carbon monoxide. So C, because there's one of them, and they do give us the prefix mono for the second element, 1 oxygen, so it's simply CO. Good luck with your homework.